On this page, we're now looking at how do we actually record variables that are within a module. So far, we talked about recording the output message, like these blue boxes, right? Per module, it becomes a message and it can get recorded through a recorder. But what if you have some variables inside? And especially when you're debugging, you might want to go, you know what, I want to see what this variable chi is doing. And so you can plot it and check it, make sure everything's working right. So that's what the script is about. And in here, we're going to create two modules. You can see nothing is connected. We're not going to bother about the execution of these modules. We're not going to record the output messages. That's not the purpose. We're just going to create two modules, configure certain internal variables, and then we're going to try to record them. And there's a Python method on how to do that. So what's needed here? We're making two message objects. So there's a mod1, that's the C message. Mod2 is the C++ dummy module, right? Not a message. Mod1 is a module, and mod2 is another C++ module. And now we have to configure them. So with these classes structures, it's always the same. It's the module name dotted with this. If it is a C module, you remember here you get a copy of the structure which contains all the data. It's like class variables for the module, but it's in C. C doesn't have classes. So this gives you a copy of the structure. And then that gets wrapped here to become an actual object that we can call and have reset and updates and so forth. But so when you set the variables for a C module, make sure you do it on the container of the class variables for the C part. For C++, it's easier because it's a class. So you're literally just setting public variables within that class. So the syntax is the same. Just don't use mod1 wrap, just use mod1. That's the data. And there's two variables here inside of this that we can set. If I go look at, I'm just bringing up the developer code here. So if you want to look at these things, for example, flight software template, this is the structure that contains all the variables that are within this C module. And you can see there's a dummy variable and a dumb vector, three-dimensional array, input output messages, and a local copy and so forth. But these are the two that are ones the user might want to set, like setting a gain or setting an offset, like center of mass offset or something like that. On the C++ side, it looks slightly different. It's the same variables that we're setting in here because the modules do the same thing, but they're simply public class variables, right? So for the C stuff, these C structures, think of them as like class variables, but we're doing it in C. Good. So these are the things we can set. That's pretty straightforward. Now we want to record these variables. And this is done, the simulation-based class that we created here, scsim. That's the kind of the main Basilisk simulation that runs all this stuff. There's a method called add variable for logging. And the way that works is it's a Python-based method. So it is not going to be as fast as other stuff. I would recommend only using this for debugging or when you really speed isn't as much of a critical issue. This is how it works. You need to give it a string to go find. And so the string needs to be the tag of the module. So for a C module, remember here, the model tag variable is defined through the wrapper. And that's why it's mod1 wrap.model tag. And then .dummy, because that way the simulation-based class can actually search the system for this variable inside this module, and then it pulls a copy. And then how often? Here we're telling it to give a copy every second, and that's it. If we want to pull this vector, this was a three-dimensional array, right? It's the same module, so that's easy. And we also want to pull it every second. And then we have to also give it these optional indices. Because this is a three-dimensional array, it would, if you didn't have these two numbers, it would just pull the first element and record a single double. But because there's now, I'm starting from index 0, 1, up to 2, so that's 3 slots, 0, 1, 2. It's going to record all 3 elements of that three-dimensional array. Now, for the mod2, that's a C++ thing. The only difference in logging is I don't have any wrapper for C++ Basilisk modules. So the tag is defined within the class. So you just do that mod2, right? That's the C++ Basilisk object module dot model tag. That will give it the right module name. dot dummy. This again, this is where it's important that you have to give things unique model tags as well. Otherwise, this logging here wouldn't work. But the rest of the syntax is exactly the same. And we can run this and we will see what the outputs are. The outputs of the C module and the C++ module should be exactly what we do. And the inputs, the single scalar is 1 and the arrays are 1, 2, and 3. Again, very imaginative. So when we bring up a terminal, I'm going to run that script and here we go. We're running it just for 1 second with 1 second time step. So there's a 0th and 1th and it's over very quickly. Then I print out the outputs and not the outputs, the logged data. And you can see here to get the logged data, it's pretty simple. It's again a simulation-based class method, get log variable data. And you give it that string, the model tag plus the dot dummy, dot vector, the dot variable name. That's what we do for every one of them to pull that. So I just put that into the print statements. And the output you can see here, when we do this, let me scroll up. So for the C module, it spits out 1 and 2 over here. But you notice it's not a 1 or an n by 1, it's a n by 2. And the reason is with this Python logging of module variables, it actually gives you an array that's buffered by 1 at the beginning, by 1 column, and that column contains your time that this variable was recorded. And the time again is in nanoseconds, a 0, and then 1 to the 9th, that's 1 second in nanoseconds. Same thing with the DUM array, that's a 3-dimensional array. You can see instead of an n by 3, it's an n by 4. And the first 2 elements in the first column, those are just the times. The C module, identical output. So the C++ logging of messages, not messages, logging of variables. Takeaway here is the syntax is just about the same. You just have to maybe get the model tag slightly differently, but otherwise it's really the same thing. And keep in mind, you can only log variables that are within either the configuration structure of the C module or their public variables like we did here within this. If I have, let me go look at the C++ code and it does something. Yeah, there's here a variable called LR. It's an internal variable only used in update states. I can't log that with this kind of a method. It has to be a class variable. Okay, so those are some key takeaways of this tutorial.